As you know by now, Cambridge has changed up a little bit. The IGCSE course now has a non-calculator paper. Now, I would not go into that non-calculator paper without knowing how to do these things. I think that would be very unprepared from you if you were to go and write that exam and not know these things. I've made a little bundle that you can download in the description that we're going to go through right now with all the topics, but just kind of quickly running through these things. Doing operations with fractions, very important. In the past, they just said, hey, don't use your calculator for this question, but now they've become a little bit smart and they said, well, you're not going to be able to use your calculator at all, and they're probably going to give you one of these fraction things. Recurring decimals into fractions, standard form. I'm kind of assuming multiples of pi would come into play in this paper, because if it's calculator paper, you can just use your calculator's pi value, but multiples of pi or exact values, things like that, would probably be in that paper. Definitely simplifying surds, rationalizing the denominator, fractional indices, and trig exact values. So these things, although we don't know what's coming in each paper, I would definitely know these topics for the non-calculator paper. Obviously for the calculator paper as well, but definitely for the non-calculator paper. As I said, I've made a little bundle for all those topics, and we're going to go through them right now. You can download it and then try it yourself, but let's go through it. I'm not going to spend too much time explaining in the sense of where everything comes from. I want to kind of I'm kind of assuming right now you know everything, and this is just kind of a revision video. So let's get into it. The question numbers are kind of random. Just want to say that it's just kind of the past papers I found them from. So it doesn't really follow any order, but I did kind of try and follow this order. Okay. So first up, let's go with work out these, like subtracting some fractions. So I'll need to get the denominators the same. So 5 over 6 is going to be the same as 10 over 12, multiplying by 2 top and bottom, minus 7 over 12. And for 2 marks, that's probably the easiest 2 marks, it's going to be 3 over 12, but it needs to be simplified. So 1 over 4 would do it. Next one, 1 and a third, I can write as 1 times 3 is 3 plus 1 is 4. So 4 over 3 divided by 8 over 15. And I don't like dividing fractions, but multiplying them is easier. So I keep the first one and then I multiply by the reciprocal. And this is going to kind of cancel out nicely. 3 goes in itself once and in 15 5 times. 4 goes in itself once and into 8 2 times. So I'm going to be left with 5 over 2. And I just want to read the instructions. Give your answer as a mixed number in its simplest form. So 5 over 2, that's going to be 2.5 basically. So 2 and a half. Just double check. 2 times 2 is 2 plus 1 is 5 and 5 over 2 and simplest form. Okay, so both are simplest form, 1/4 and 2.5. That was it, fairly simple. Definitely know how to do those. Let's get into the next one. They're writing or asking us to write 42 as the product of its prime factors. So a little factor tree is going to work out nicely. So if I have 42, you can do a little ladder thing. I like the trees. So 21, and then that should be 3 and 7. So 42 written as prime factors is just going to be 2 times 3 times 7. So that should be fine. Next one, the highest common factor. So there I'll do factor trees again. So I have 80, 84, and that's going to be 2 and 42. And then we have the same tree as above, which is just going to be 2 and 21 and 3 and 7. So I can write 84 as 2 times 2 times 3 times 7. So that's 84. And then for 70, we'll do 2 times 35. And 35 is 5 times 7. So then for 70, I kind of write these numbers below the ones here. So I'll write the 2 there. There's no 5, so I'll put the 5 times there. and the 7. And then to find the highest common factor, I would just multiply everything that was kind of the same or matches up. So that's 14. And just a little note, if you wanted to find the highest common or the lowest common multiple, you would multiply 2 times 2 times 3 times 7 times 5. Okay, but yeah, that was it. Very straightforward. I don't see you losing any marks on those. Let's take a look at the next one. So work out 5 over 9 plus 0.25. Well, sorry, 28, and the 8 is recurring. Give your answer as a fraction in its simplest form. So the first part would probably be trying to get that 0.28 recurring as a fraction. So we start off with x is equal to this, and 10x is then going to be 2.8 recurring. See, it's not lining up, so 100x and 28.8. So kind of that part and that part would cancel out if I minus it. So 100x minus 10x is 90x, and 28 minus 2 is going to be 26, and then dividing by 90 both sides, so 26 over 90. Do I have the right color pen? That one seems a bit dry. Sorry about that. Let's try again. So I have my recurring number as 26. Oh, that looks much better. 26 over 90. And the 5 over 9, I can probably write as they're adding it, so 50 over 90. That should be fine. So then we have 76 over 90, but I believe both are even numbers, so that should be 35, 6, 7, 8. So 38 over 45. I think that's going to be the simplest form. So yeah, a little bit of a trick having to get the recurring number and then adding it to a fraction, getting the denominator is the same, but yeah, I think that should be easy enough. So for our next one, we have write something in standard form. So we have 0.007, so standard form will need to have that 7 first, followed by decimal 0.08 times 10 to the power of something, and I move this decimal point 1 to 3 times, but it's a smaller number, so it has to be -3 because I'm obviously dividing. If I put a +3 here and I multiply, I'm going to get a big number like 7080, but because 1, 2, 3, but this is a -3, so I need a smaller number. Next up, this question usually catches out a lot of students, so let me just rub this out and we can take a look at this one. So work out having two kind of standard form numbers there, but the catch is that's to the power of 22 and that's to the power of 23. So I usually want to try and get to keep the bigger number and write the smaller number as a bigger number. So the 10 to the power of 22, I'd like to write it as 10 to the power of 23. So because I multiplied by 10 there, I'll have to divide by 10 there. So this will become not 3.8, but 0.38. And then plus 3.8 times 10 to the power of 23. So now I have like terms and I can add them. You can think about it as like 2x squared plus 3x squared. I can add those to make 5x squared, but if this was cubed, then I couldn't add them. Now the lucky thing is because this is multiplying by 10, I could actually change this the 22 there into the 23 here, which with normal algebra I can't really do. So let's take a look here. So now it's just going to be 3.8 plus 0.38, and that's going to be, well, that's 8, and that's 11, so that's 4.18. Very important, give your answer in standard form. So there's 4.18 times 10 to the power of 23. Very important that we only have one digit here. If you ended up making both to the power of 22, then you would have ended up with 41.8 times 10 to the power of 22, which then you would have had to convert to this. But yeah, I think that's easy enough. Nothing tricky yet. Well, I guess it might be a little bit tricky, but let's go. Next question. Simplifying surds, very, very important. So also a little bit of a different question, not just a basic, hey, simplify the surd. But they're giving us two surds here, so we have to kind of find the square numbers in there. So 27 is 9 times 3. And then 12 is going to be 4 times 3. And I can already see what's going to happen here. So the square root of 9 is going to be 3. So that's going to happen. And the square root of 4 is 2. So that's going to happen. And now I have 3 plus 2, basically just 5, the square root of 3. And that's my final answer. Also a little bit of a different one here. We have 40 over the square root of 8, well, 40 times the square root of 8 over 5 square root of 2 is equal to k, where k is an integer. So now we're going to have to find that integer. So I'm going to first off start with the 40 over the 5. So I'll just write this out and then I can scratch out all I like. So 5 square root 2. So the 5 can go in itself once and into the 40, 8 times. And then I'm going to be left with this kind of square root thing at the bottom, and I don't like square roots as denominators, so I'm gonna rationalize the denominator, and by doing this I'm gonna be left off with 8 times the square root of 8 times the square root of 2, and here I'm just gonna have a 2 at the bottom, and that 2 is gonna cancel it out with the 8 at the top. And then 8 times 2 there is actually going to be 16. So I'm going to be left with the square root of 16 times 4 all over 1. I'm not going to write. Okay, let's write it. And then I'm left at the end with 4 times 4 because 16 square root of 16 is 4. And then 4 times 4 is just 16. Yeah, let me just double check. Yeah, that should be good. Kind of a, yeah, I like this question. Very, very cool. Then number C, like this question just keeps on getting better. So they're asking us to rationalize the denominator, 3 minus the square root of 5. And this one has a trick. So instead of just multiplying by the same thing, I'm going to multiply by 3 plus the square root of 5. Top and bottom, 3 plus the square root of 5. So at the top, we're just going to have 3 plus the square root of 5. It's just going to stay like that. But at the bottom, it's kind of going to have this neat trick. So basically, I'm just going to say 3 times 3, which is 9. The negative 5, square root of negative 5, negative square root of 5 times 3, and the plus square root 5 times 3 is going to cancel out. So basically, I'm just going to be left with this minus 5 at the bottom. And that's just 3 plus the square root of 5 over 9 minus is 4. And I can't do anything different there, so neat trick, 2 marks, quick and easy. And then for last one here, just from a different paper, write 0.328, etc. Okay, so let's go take a look. How will we do this one? So same thing, x is equal to 0.328, and only the 2 and 8 are recurring. So I'm going to follow the pattern just to see where it leads me. So the 2 and 8, that's going to be fine. I know the 100x won't work, but I'll just write it anyway. So 32.8. Let me just write that better. Sorry, 32.8. 28, so the 2 8's kind of trailing there. They're not lining up yet. I need something to line up with that. So 1000x would work. So 328.28 recurring. So now I can see those trailing bits are gonna be fine. So I have 1000 minus 10, which is 900x. And then we have 328 minus that 3, and the whole recurring bit, that's going to cancel out. And then we're left with 325. And then x is going to be 325 over 900. I have a feeling 3 is going to, 3, 4, 5, no, 10, 5 should go in here. And now I don't have a calculator. Oh, no, I'm stuck. How many times will 5 go into 300? Five might be a bit small. I'm not going to think. Maybe 25? So 25, yeah. So there's about 4 25s in every 100, and there's 300. So it's going to be 4 times 3 plus 1, which is 13. And then basically 4 times 9, right? So that's 36, and 13 is a prime number. So yeah. Okay, yeah, it would have taken me forever to figure out how many 5s, and then we would have had to reduce even further. So yeah, I got lucky there. Cool, thanks. Anyway, let's carry on. Let's carry on. What's next? Okay, next one is a bit of expanding brackets. So this seems to, yeah, something's going to cancel out here. But I think they're, yeah, let's just start over there. So first times first is going to be 2 times 1, which is 2. And then we have this negative square root of 5 times 1, which will just be negative square root of 5. And then we have we'll do the 2 times the negative 3, which would be negative 6, square root of 5. And then last, we're going to have negative times negative, which would be positive. And there's a 3 there. And that's multiplied also by square root of 5 times square root of 5, which will just be 5. So not 3.5, but that's 3 multiplied by, okay, let me just do it like this. It looks better, maybe. These are like terms, actually. So we're going to have the 15 and the 2, so that should be 17. And then minus 7 square root 5. Is that fine? So I had 1 and 2 times 3 is 6. That should be fine. Yeah, I think that's fine. Can't really go further than that. That's that. Next one, rationalize the denominator. Give your answer in its simplest form. So 6 square root 10. So let's just write that, 6 square root 10. So we kind of have to multiply with square root of 10 top and bottom. So we're going to be left with 6 square root of 10 over 10. And then we should be able to reduce this a bit further. So 2 can go in there 3 times and there 5 times. And there you have it, 3 square root 10 over 5. Easy does it. Okay, and number 19, we have some fractional indices. These are probably my favorite. I don't know who thinks these things out, but they make my life great. I really love these questions. So with the 27, I'll just write that a little bit bigger so you can see. Maybe you can't see it watching on your phone or something. So 27, and then we have 2/3. Now that 3 is kind of a giveaway. This 27 is going to have to be written, well, it is a cubic number, so 3 to the power of 3. So just writing 27 as 3 to the power of 3. 3 times 3 is 9, times 3 is 27. And then we have this negative 2 over 3. So this 3 and that 3 will actually cancel out when we multiply. So we're left with 3 to the power of negative 2. They just said find the value. So I'm going to go with, well, this is now 1 over 3 squared, which is just a 9th. I believe that would be good enough for them. I wouldn't really leave it as a negative indice. So 1 over 9, that should be fine. Are there more? Yes, there's more. Who knew? More. Let's take a look at these. This seems a little bit intense. 81m to the power of 8, 3m squared, and all to the power 2 to the power of 3. Now, usually what I'd like to see is I'd probably want to make 81 3 to the power of 4 and things, but I'd probably simplify this first before I continue on there. So 81 divided by 3, that should be 27. And then indice rule, that should be m to the power of 6. So I think that is probably the best route to go. And now the 27 I'll write as, because that's a 3, I think 3 to the power of 3 is probably a good idea to follow. So 3 to the power, well, this times that is just going to be 3 squared. And this times this is just going to be m. I'm just going to do it long quickly. So that's going to be 6 over 1 times 2 over 3. And that 1 and that 2. So that just becomes a 4. So this should just be 9m to the power of 4. Yeah, I think that's going to be fine. 12 over 3, that's 4. Okay. Yeah, that's good. Cool. Next one. Yeah, that one looked a lot worse than it was at the end, didn't it, Wayne? This one looks even worse. So 32x to the power of x times 2 to the power of x plus 3 is 1 over 4. So I kind of see that 2 is a base there, so I should write this as 2. Now I can't remember, is it 2 to the power of 5 or 2 to the power of 6? So 2 times, sorry, I should have maybe 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So 1, 2, 3, 4, 5. Okay, so that's 5. And then it's just going to be multiplied by that x, so that should be fine. Multiplied by 2x plus 3. And this is actually a quarter is the same as 1 over 2 to the power of 2, which would be the same as 2 to the power of negative 2. So 2 to the power of negative 2. They did say find the value of x, so this is, I would just be adding these things. The bases are the same, so those would be added. So basically 2 to the power of 5x plus 1x is 6x plus 3, and then 2 to the power of negative 2. So this will just be equal to that. So 6x plus 3 is equal to negative 2. Taking that over, 6x is going to be negative 5, subtracting 3 on both sides. So x is basically negative 5 over 6. And that's it. Okay, cool. I say cool a lot. Sorry about that. I was just really excited, I guess. Okie dokie. Let's try that. Find the value of 125. Okay, this one seems a little bit easier. So 125, whenever I see kind of this number 125, I immediately think 5 to the power of 3. And then to the power of 2 over 3. And then the 3 and the 3 is going to cancel out. So 5 to the power of 2, which would just be 25. Okay, simple one. This one's going to be very much the same. So 4 is 2 to the power of 2, and that's all to negative 5 over 2. 2 and the 2 is going to cancel out, so I'll be left with 5 to the power of, oh, sorry, not 5. Probably confused you there. 2 to the power of negative 5, which would just be 1 over 2 to the power of 5, which is, they said find the value, so we'll just 1 over 32. Cool. Next one. So there's a diagram here, and there's some solids and etc. And this is now something typical. So our answer is going to be in multiples of pi. So there's 3 parts here. There's a circle at the bottom. There's a cylinder, the curved part of the cylinder, and the what's that sphere? Hemisphere. So I should have my handy little formula sheet, which you will be supplied with. So the one part is going to be the circle, which I know is just pi r squared. They're asking for the total surface area. The next part is going to be the round part, which is basically the diameter times the height. So it's going to be 2 pi r h, which you can find on the formula sheet. And the one that I don't always know is the surface area of a sphere, but we have a hemisphere. So it's basically half times, let me just find it here, 4 pi r squared. Okay, surface area of a sphere is 4 pi r squared. Okay, so that should be fine. And now we just have to fill in our parts. So this is the circle at the bottom. So that's going to be 6 squared, which is 36. I'll just write it immediately as 36 pi, because it's 6 times 6. Then we have 2 times pi. The radius is 6 and the height is 5. Okay. I'm going to cancel the half and the 4, so I'm going to have a 2 and then pi, and then this radius is also going to be 36. Okay, so I have 36 pi plus, that's going to be 30 times 2, it's 60 pi, and then plus 72 pi. And adding all of that together should be 60, 70 is 130, 40, 50, 60, 160, and the 6 and the 2 becomes 8 pi, 168 pi. So it seems very intimidating. It was 4 marks, but it was just keeping, I guess the tricky part is here, not forgetting there's a circle at the bottom, and then making sure which radii you use. Well, not radii, the one is the height, making sure the radius is actually always everywhere the same. It was just the height of the 5 that we had to make sure. Okay, next one, have some trigonometry. We're gonna have to. No, not yet. Still multiples of pi. This one doesn't need any trigonometry. So they're asking for the value of n. The length of the arc is n pi. So arc. Okay, so they gave us the angle, so we know the arc is going to be 45 over 360 times 2 pi r. Now there's 8 of these half of 90 times, so this is 1 over 8 times, I'm just going to put 2 pi, and the radius there is 18 over 1. That 2 can go in itself once, and then 8 4 times, and then 2 can go in there, and in there that's going to be 9. So basically we're going to have 9 at the top, 9 pi over 2, which is the same as 4.5, but 9 over 2 or 4.5 pi. But they're asking just for n, so n would be 9 over 2 or 4.5. Next question, we have some trigonometry, some exact values. So before I start, there's a couple of ways to find the exact values. I'm not really good at memorizing, let's say, tables, although they are sometimes, I can probably do it, but for me the easiest is just to kind of make sure that I know these triangles. So this is the one triangle. Let's say if this is 1, this is 1, this is going to be the square root of 2 if you use Pythagoras. And then I know that's going to be 45. You can't see it there, and 45. So then using this triangle, I can find out what is the sine and cosine of 45, etc. So that's one way. This one is 30. So I'll use a different triangle. If I remember correctly, I'll think of a triangle that's equilateral. So that would be 6. Okay, maybe I'll just draw this one a little bit bigger. So I'll think about an equilateral triangle, which is 60, 60, and 60. And then I'll have these sides all 2, and I'll split it down the middle, which means that this side is 30. So I'll just kind of redraw this. So there will be 60 here, 30 there. That length is 2. And this length, because it's split in half, is going to be 1. And if I use Pythagoras, then this will be the square root of 3. And then I can use this triangle to figure out what is, let's say, the cosine of 60 is going to be 1 over 2, or the sine of 60 degrees is going to be the square root of 3 over 2, or whatever. Maybe if I wanted the sine of 30, then it's going to be 1 over 2. So this triangle I can kind of switch around and figure out what those exact values are, or you can memorize the table. In this question, they're saying find the exact value of x. And if I look here, this is 30 degrees. So this is opposite and that's adjacent. So I'm looking for tan of 30 degrees is going to be the opposite, which is 6 over x. And the tan of 30, if I use this angle, tan of 30, tan 30, if you don't know this, it's going to be 1 over the square root of 3. But we don't really love having... Okay, I'm just going to fill that in anyway. 1 over the square root of 3, that should be fine. 6 over x. And with this kind of thing, I know those two multiplied with each other will just give me an answer. And those two will give me another answer. So 6 square root of 3. That seemed way too quick for 4 marks. Let me just double check. This is 30. Tan would have been opposite over adjacent, which is opposite is over adjacent. Yeah, should be fine. And then we just put tan. Yeah, okay, that's fine. Cool. Let's go on to the next one. I guess the tricky part was just remembering the triangles. Is this the last question? No, we have some more coming up. Kind of a long video. Hopefully I'm not talking too much. Write down the value of cosine 90. Okay, these are one of the things that you'd probably just have to memorize. I know that sine will always give me the vertical displacement and cosine would give me the horizontal displacement of any angle. For example, any angle, if I wanted the sine, that would give me an idea how high I'm moving, and cosine would give me an idea how far I'm moving. I've kind of remember it as if someone says, oh, give me a sine, they usually look up into the air. So if I'm looking for the cosine of 90, 90 means I'm just going straight up and there's no horizontal movement. So the cosine of 90 will just be 0. Okay. Yeah, that's it. Nothing tricky there. It's kind of just memory. For the next bit, 2 different right angle triangles joined by a common side. Find x in terms of n. There's an x there and an n there. So looking at this triangle, I'm going to go with, let's say that is the hypotenuse and this is a shared angle. So I'm probably going to go that route. This is the adjacent. So I'm going to go with cosine of 30 degrees is going... Oh, no, I deleted my... or deleted. I took away my little triangle. But anyway, I'll draw it at the bottom here. So cosine of 30 is going to be the adjacent, which I don't know what that is. I'll just make it A for now, over x. That makes sense. And if I drew my little triangle here, remembering there's a 30 there and a 60 here, and this is going to be 1, and that's 2, and that's square root 3. So if I'm looking for the cosine of 30, it's going to be adjacent. So the square root of 3 over 2. The square root of 3 over 2 is a over x. And now I want to just write this in terms, in terms of this a. So I'm going to multiply with this x. So a is just going to be x square root 3 over 2. Okay, so that's that part done. So now I know that length over there is this thing, whatever this thing is. Next up, we have to find this n, and that's the sine. So I know the sine of 30 is going to be the n over, this is my hypotenuse, but this thing is that thing. Ooh, this is going to be ugly. Okay, so sine of 30 I know is a half. Okay, so that's a half is equal to this n is there over this whole ugly looking thing. But now I know if I cross multiply, it's going to be fine. So this, which is, this is a lot of marks. 3 over 2 is equal to 2 times n, which is 2n. And then I want x alone because they said find x in terms of n. So times 2 on both sides. So x to the power of, well, not to the power of, x square root of 3 is going to be 4n. and then ending up x should be 4n under square root 3. If you don't want to leave it like this, it's just going to multiply with square root of 3 top and bottom. Maybe that would be smart to just kind of have this in the end. I can see 5 marks in there. Yep, that was a bit intense. So we had to look, know the exact values and then do this little trick with the putting the one into the other one. Wow, that was it. That was a question and a half. And then the last one, it's the end. Finally there. Let's quickly take a look at this one. Hope it's not too tough. Diagram shows 2 right-angled triangles, and then find the value of cosine ADC. So ADC, that's kind of that angle we need. I'm going to start with a triangle that I have the most information of. So this one. So this is opposite and that's adjacent. So it's going to be the sine of 30 degrees is opposite, which is 6 over that AC. And I know the sine of 30 is going to be a half, is 6 over AC. And if I rearrange this, it's basically just going to, well, the AC is just going to be doubled, right? So AC is going to be 12. And then I have a triangle with 9 and 12, which should kind of, my guess is, I know the 3, 4, 5 triangle, so my guess is this is going to be 15, but let's just see how that works out for us. We're going to have to use Pythagoras, so basically to get that we have to do the square root of 9 squared plus 12 squared. So that's going to be 81 plus 144, which would be 225. Yeah, it's going to be fine. So that length was 15 indeed. How I knew this is that we have, usually if we have 3 and 4, then that would be 5. It's kind of a pattern. So I just saw that this is a similar triangle. So 3 times 3 times 3 is 9, and 4 times 3 is 12, so 5 times 3 is the 15. That's kind of where I got that from. So now we have to figure out, they said cosine ADC. So cosine in this triangle, this is going to be adjacent. So cosine of ADC. So this is my opposite, that's my adjacent over my, so that's a 9 actually. It's a 9 over, and then we worked out that one is 15. So it's 9 over 15, or it could be 3 over 5, if I'm not mistaken. Yeah, divided by 3, divided by 3. Okay. And that's it. So I hope you're ready for your non-calculator paper. Please make sure you understand all of these topics. Not making any prediction saying everything will be asked, but definitely make sure you're well prepared.